Use mathematical induction to prove that for every positive integer n, 1 plus 4 plus 7 plus all the way up to the quantity 3n minus 2 will equal n times the quantity 3n minus 1 all over 2. So that means we first have to prove this is true for n equals 1, then assume it's true for n equals k, and using that prove that it's true for n equals k plus 1, in which case that would show it's true for all positive integers n. So starting with showing it's true for n equals 1, here is our equation. Well, if we look at what the nth term will be when n equals 1, that would be 3 times 1 minus 2, and that equals 3 minus 2, or 1. And that should equal on the right 1 times the quantity 3 times 1 minus 1 all over 2, which equals, we don't need the 1, so this is going to be 3 minus 1 all over 2, or 2 over 2. And we can see 1 does indeed equal 1. And so it's true for n equals 1. So we're going to assume that it's true for n equals k. Well, if n equals k, then what we have is we take our original equation, and in our original equation, we replace the n with k. And so we can see that this was our equation, but instead of n, we're showing it's true for k. So given that, we need to prove it's true now for n equals k plus 1. Well, here was the left side up to the kth term, so we have to add the k plus 1 term to that quantity now. And that should equal the k plus 1 term on the right. Well, if we look at this quantity here, we can see that that's what we had when n equaled k, so that should equal k times 3k minus 1 all over 2. Then here we have 3k plus 3 minus 2. And on the right we have k plus 1, and if we multiply this out, we have 3k plus 3 minus 1 all over 2. Now I can multiply all the way through by 2 to get rid of my fractions. When I do that, the 2's cancel on the left, and we have k times 3k minus 1 plus 3k plus 3 minus 2 is 3k plus 1 multiplied by 2. That's out in front because there's no 2 to cancel. Should equal, the 2 will cancel on the right, leaving k plus 1 times 3k plus 3 minus 1 will be 3k plus 2. So I have 3k squared minus k when I multiply this out, plus 6k plus 2 when I multiply or distribute the 2 through. On the right, using FOIL, I have 3k squared plus 2k plus 3k plus 2. On the left, that gives me 3k squared. Negative 1 plus 6 is plus 5k plus 2. On the right, I have 3k squared. 2 plus 3 is plus 5k plus 2. I can see that those two are equal, so that means I've proven that this is true for n equals k plus 1, and I'm done.